Make you do proofs. All right, so anyway, so what you're going to do, again, all you're doing is Pythagorean theorem. So like this is like the length you're finding, and then this is like your change in x, and then this is like your change in y, because it's like up and down, and you're just doing like straight up Pythagorean theorem, right? So you're doing that squared plus the y's, change in y squared, right? But like we're not doing straight line, we're doing curvy stuff. So we have to like mess with the formula so we can attack the curve part of it. So what happens is they factored out the change of x squared, like actually factored it all the way out. Maybe I'll get rid of the parentheses, it's easier to see. And then what's left is 1 for the first term, like once you take it out. And then with the change in y, wait, why is that squared there? Hold on. What it ends up looking like is you get change of y over change in x, which is derivative, right? So that's like the goal is to get that. And then if you take the square root of change in x, you can take it out of the radical. So it ends up being 1 plus change in y over change in x quantity squared times change in x, which you guys already kind of know. That's going to be your dx, you know. So like we have the integral because you're like adding them all up. It's like an infinite amount of like segments you're finding, right? And then you're just adding all these up. To get them all up, getting them. So, and you can do this in terms of dy too. It's just, instead of f prime of x, it's going to be f prime of y. So it's really like pretty similar to that anyway. Actually, maybe I'll do c to d. So, and you can have it like, if you want to go wild, you could put the derivative first. It doesn't matter. But you could do it in terms of y as well. So, but yeah, it's just Pythagorean theorem. The 1, again, the way you can remember it, the 1 is because you had to factor out the change in x. So you can use the derivative. That's how I remember it. So, if that helps you, it helps you. If it doesn't, whatever, put it in your brain. Okay, that's the formula for it. So now, like here, it would be nice if I could just do straight line. Then that would be like normal, like algebra problem. Guys, okay, it's just a normal algebra problem, but since it's all curvy, you're going to be doing the arc length formula. So basically what you do is you take the formula, you've got your interval 1 to 4, so you're going to integrate from 1 to 4, and then you just kind of follow the formula. It's Pythagorean theorem. And then you need to plug in the derivative of f. So it's really not bad. You're like, what's the derivative? 2x. So, and that's all you do. So just for setting up, that's all you have to do. Okay. For this question, for integrating that's very difficult. Actually, you don't know that method yet, so this would be a calculator problem. So, all right. So notice this guy, like the way you know it's going to be in terms of y is like, I mean, this one's kind of easy because they're telling you intervals for y, but also like, if you were to do it like left to right, it's like you're going over itself. So doing it in terms of x doesn't make any sense because you're like going over yourself. Do you know what I'm saying? Like you're going left and then you're going back this way. So that's another way to know you're doing y, because if you're doing it in terms of y, you're only looking this way or hitting every value just once. So for this one, you're going to do L equals, and then you're integrating on this interval. And again, this is just from, we're looking at the y's. Say they didn't give it to us. But it's like we're integrating from here to here. We're counting up all the little tangent line distances. from 3/2 to 3. And then I'm doing Pythagorean theorem because I have to add up all those little tangents. It's going to be 1 plus, and then I'm going to find the derivative. Whoops. I almost died. I put dx. I'm going to do this in terms of dy because I'm doing all y stuff. So now what you're going to do is just find the derivative of f prime of y. You don't have to do like chain or anything because you're taking a derivative with respect to y. So you're not going to do like chain rule or anything. It's just like normal derivatives. So this is just a quick, well, I guess this one is chain. You're going to go 8 and then 2 minus y times -1. And then you would throw it in the formula. So what I'm saying is you don't have to multiply like y prime, right? You're just doing derivative with respect to y because you're integrating everything with respect to y. So then you throw that in, and then that's it. Okay? It's not too bad, right? Maybe? It's kind of just the formula. And then, of course, they'll try to be weird, you know. So, like, this multiple choice makes you, like, have to think more. So, find the curve which contains the point 0, 3, whose length from 1 to 4 is given by that equation. So, now it's like you have to get the function out of that, the original function, right? So, finding the curve, it means, like, you need to find, like regular f of x, you know what I mean? So as long as you can like dissect the formula, you should be fine. It's basically what I do is I know the 1 plus is always like the thing with the formula. So I always know there's going to be the 1. And then remember, you're always squaring the derivative, right? So basically just take the square root of whatever's in there, right? So like if you were going to square 16, you know, and get 16x to the 6th, it would be 4x cubed, right? And of course, that's an option, right? People are going to circle A and be like, oh, yeah, I'm done, blah, blah, blah. But remember, this thing, that's the derivative, remember? So, like, just be careful because this one is always going to be an option. So just make sure that you like rewrite, like figure out what regular f of x is. So that's just doing an antiderivative, right? So that's what? Right, x to the 4th. So then you're like theoretically feeling good. And then you're like, okay, so I have a and c, but now it's like what? You know, because I have like 1 with a 3. And you're like, well, because technically this is like plus c. Right? So what you do now is you just look at the containing point problem, right? So it has to contain the point 0, 3. So that's how you can narrow it down. So if you do f of 0, because of that, it has to be d, right? So order pair, whatever you want to think about. Okay? All right, do you want to try doing the bug? You can use the calculator. So why don't you just practice? It's fun. Ready, number 4. Find the length the bug traveled, because these are things we need to know. Yeah.
Yeah, I know. I just now that went to speak.
Oh, you forgot the 2 on the cosine.
Oh.
There you go. Phew. Did anyone get it yet? No.
No.
Yeah. I don't know why.
Did I plug it in wrong?
You might have.
You didn't have a square root.
That's the problem.
Is this right?
Oh boy. Yeah, that's right. That's right.
So I just want you to know about that. I don't want to do this yesterday, so I have all of them.
Oh,
I'm just considering.
but now you get to listen.
I was just like, let me cook.
Yay!
Those were all the ones I never got a point. Yeah, we already.
I'll talk to you in unit 9. Say that again. Unit 9 is horrible.
Yeah, we already got to ignore it. Like, we wouldn't be here if we didn't pass.
All right, so that's the answer. Good. Just kidding. Okay. All right, this one. This was on a pretty recent BC test. It was kind of a weird one, but whatever. It says, this was part A, and then part B, they were doing like the area, and then they did like the revolving. Like this was one of those like volume problems on the F or Q. But part A like started off strong with some BC knowledge, but it said, guys, stop talking, please. First quadrant, bounded by the graph of F, the coordinate axis and the vertical line x equals k, where k is greater than 0. Region R is shown in the figure. Okay, cool. Right, but do not evaluate an expression involving an integral that gives the perimeter of R in terms of k. So first of all, what it means when it says in terms of k, it means like k is going to be in there. That's just what it means. Like you're just going to have an equation with k's in there. So you have to find the perimeter, so it's like a weirdo trapezoidy looking thing, you know? So some of the lengths are like more normal, if that makes sense. Like this thing, you know, like it's just one, right? So like to find the perimeter, actually I only need an expression, so I don't have an equal sign. But this part, that's just like plain 1, you know what I mean? Right? Because it's just like a length. So it's going to be 1 plus, and then you're going to go, wait, I'll do rainbow. This length, and you're like, just look at the length. So it's from 0 to k, and you're like, but it's a variable. Who cares? Just write k. Okay. And then this thing, again, straight up vertical. Don't like be too crazy, you know? So the vertical is just the like up and down, like straight up y. So e to the 2k. And then what makes this question fancy is you have to find the length of this thing. So again, if it was straight line, I would be in Algebra 1, right? Doing like distance formula. But like, since it's curvy thing, we're all calculus-y and fancy. So we're going to find the length. And because my equation is in terms of x, I know my integral is going to be with x. So I'm going to add up all the little tangents from 0 to k, because those are your x's, right? Square root 1 plus quantity squared dx. And remember, the way you figure out like that in that part in there is just the derivative. So what you're going to do is you're just going to find f prime, and it's 2e to the 2x. And then that's it. So that's all you have to do. It's kind of fun.